everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square plus d into y equals to cos x. Solution. Given differential equation. D square plus d into y equals to cos x. So let's find the order and degree of the given differential equation. We can write this as d square y plus dy equals to cos x. We know that differential operator d equals to d by dx and d square equals to d square by dx square. Then you can write the given equation as d square y by dx square plus dy by dx equals to cos x. Now identify the highest derivative here. D square y by dx square is the highest derivative, so our order is 2. And the highest power of the highest derivative, okay, is degree. So here 1 is the degree. We are given a differential equation which is in operator form, f of d into y equals to q. Where f of d equals to d square plus d and q equals to cos x. Now we need to find the general solution to the given non-homogeneous equation using y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll write yc using roots of the auxiliary equation of the homogeneous equation of the non-homogeneous equation. Simply we'll consider, or we'll just take RHS as 0, then we'll get the non-homogeneous equation, the homogeneous equation of the non-homogeneous equation. Okay, homogeneous equation of the non-homogeneous equation. Now we'll find yp using 1 by f of d into q, right? So let's find complementary function firstly using auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d square plus d. Let's replace d by m, then you'll get f of m equals to m square plus m. Then our auxiliary equation becomes m square plus m equals to 0. We can take m common from the two terms. You'll get m times m plus 1 equals to 0. Equate each factor to 0. Then you'll get m equals to 0, m plus 1 equals to 0. M equals to 0 is 1 root, and from m plus 1 equals to 0 you'll get m equals to minus 1, which is another root. So you'll get m equals to 0 minus 1 are the roots of f of m equals to 0. Okay, our auxiliary equation, which are real and distinct. We know that when two roots say m1, m2 are distinct, then we can write the complementary function y is equals to c1 e power 1 root into x plus c2 e power another root into x. Right? Likewise, for m equals to 0 minus 1, we'll write the complementary function y is equals to c1 e power 1 root 0 into x plus c2 into e power another root into x, which is equals to c1 e power 0 into x is 0 plus c2 e power minus 1 into x is minus x, which is equals to c1 e power 0. Since e power 0 equals to 1, then you will get c1 plus c2 e power minus x. Therefore, yc equals to c1 plus c2 into e power minus x. Now let's find the particular integral. We know that we'll find particular integral 1 by f of d into q, which is equals to 1 by f of d. We are having d square plus d into q cos x. Here we are having q is in cos ax or cos bx form, right? For a or b equals to 1. Now, we are having yp equals to 1 by d square plus d into cos x, right? Here, let's find d square, which is equals to minus a square, okay, for a equals to 1. Okay, if you consider it as cos a, if you can see, if you notice, you're having cos into some 1 into x, which is in cos ax form, right? For a equals to 1, you'll get minus 1 square, which is equals to minus 1. So we need to replace d square by minus 1 and see whether the denominator is equals to 0 or not equals to 0. Let's check it. Replace d square by minus 1. Then you will get 1 by d minus 1 into cos x, right? See here, the denominator is not equals to 0 after replacing d square equals to minus 1. So, we can replace d square. Replace d square equals to minus a square equals to minus 1 square, which is equals to minus 1. Then we'll get 1 by minus 1 plus d into cos x, which is equals to, again you can write this as d minus 1 into cos x. Now what we'll do? We'll just multiply and divide with d plus 1. See here you're having minus, right? So we'll use d plus 1 in the numerator and in the denominator into cos x, which is equals to d plus 1 by d minus 1 into d plus 1. Otherwise, you can write it as d plus 1 into d minus 1, which is equals to d plus 1 by, this is in a plus b into a minus b form, which is a square minus b square, is equals to d plus 1 by d square minus 1 into cos x. Now, in the denominator, let's replace d square by minus 1 and see what we'll get. Consider d square minus 1, which is equals to minus 1 equals to minus 2, which is not equals to 0, right? Since the denominator is not equals to 0 after applying d square equals to minus 1, so what we'll do? We'll just replace d square equals to minus 1, right? Then this becomes d plus 1 by d square can be replaced by minus 1 into cos x, which is equals to d plus 1 by minus 1 is minus 2 into cos x. If you get denominator equals to 0, then the total term becomes undefined. Okay, we should not get 0 in the denominator. Now, we are having d plus 1 by minus 2 into cos x. You can just write this as 1 by minus 2 into d plus 1 into cos x, right? Now write 1 by minus 2 as minus 1 by 2 into d plus 1 into cos x, which is equals to minus 1 by 2 into d cos x plus 1 into cos x is cos x. Derivative of cos x is minus sin x plus cos x. This becomes minus into minus plus, right? Minus into minus plus 1 by 2 into sin x. You can just write it as sin x by 2 otherwise. Minus into plus minus 1 by 2 into cos x is cos x by 2, right? Or simply write this as minus 1 into minus sin x plus cos x by 2, which is equals to minus 1 into minus sin x is sin x, minus into plus minus 1 into cos x by 2. Okay, also from sin x by 2 minus cos x by 2, to take the LCM, you will get sin x minus cos x by 2. You will get the same thing. If you want to multiply 1 by 2 minus 1 by 2 with these two terms, then also you will get the same thing. Or you can just multiply minus 1 with, or numerator with the terms under square brackets by 2. Fine. Now we got yp. Yp equals to sin x minus cos x by 2, or you can just write it as 1 by 2 into sin x minus cos x. Okay, you can just multiply the terms under square brackets with minus 1 simply. Okay, then you'll get this. Otherwise, you can do like this. It's ourish. Now we got yp, which is sin x minus cos x by 2, or 1 by 2 into sin x minus cos x. Now we can write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, c1 plus c2 e power minus x plus yp sin x minus cos x by 2, or can write the general solution as plus 1 by 2 into sin x minus cos x. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Till then, bye bye.